Alright, airplanes are heavy, really heavy. And cars are heavy too, but not nearly as much. Yet, what floats among the clouds like a butterfly while the other lumbers around on tarmac? How in the world does that work? To understand, let's look at the four forces acting on an airplane. There's gravity, thrust, lift, and drag. Thrust and lift are kind of the only things that we can control, so let's see how they work. Let's start with thrust. It's a mechanical force generated by a propulsion system, which can be a propeller, a turbine, a ramjet, or a rocket. Remember Newton's third law? Every action has an equal opposite reaction? That's the basic principle behind thrust. A working fluid is accelerated by an engine, and the reaction to this acceleration produces a force on the engine in the opposite direction. There's an equation derived from the second law of Newton called the general thrust equation, and it looks like this. We'll ignore this part right here because P represents pressure and A represents area, and gas turbine engines, which is our main focus, are designed to have the same amount of output pressure as input pressure, which cancel out. And so we're left with this, where m dot is equal to mass flow rate, which is thus the amount of mass passing a plane per unit of time, and where v is equal to velocity. Now there are two things we can do to get really high thrust. We can either have really high mass flow rate and a small change in velocity, or a small mass flow rate and a big change in velocity. You only have to make sure that the exit mass flow rate times velocity is greater than the free stream mass flow rate times velocity, so that F can be positive. I'm going to wear a hat now because it's Texas. So that means you can either accelerate a large mass of gas by a small amount, or a small mass of gas by a large amount. Turns out the first method is more fuel efficient, and so that is the design theory that airliners follow. Let's move on to lift. This is an airfoil. Two main simplified physical explanations for lift. The first is the Newtonian explanation. It says the airfoil deflects the flow downwards. This deflection requires a downward force applied by the airfoil on the air, and so by Newton's third law, the air must exert an equal and opposite force on the airfoil. The top surface also deflects the flow downwards by the Coanda effect, which says a fluid jet will stay attached to a convex surface. The reaction on the airfoil makes it go up. The other explanation is based on increased flow speed and Bernoulli's principle, which basically says more speed, less pressure. There's a common incorrect explanation which says that apparently air traveling over the top and air traveling from the bottom must meet the trailing edge at the same time, and because the top is curved, the air has to travel faster and have less pressure according to Bernoulli. Yeah, no. The air doesn't have to meet up at the back at the same time. This is wrong, wrong, wrong. Instead, due to the angle of attack of the airfoil, the upper stream becomes narrower and the lower stream becomes wider. Because of the law of conservation of mass, the air over the top must flow faster and therefore have less pressure according to Bernoulli's principle. This lifts the airfoil. Now, which of these theories is correct? Well, both of them are, and they both work together to form a more comprehensive explanation. There is actually a pattern of non-uniform pressure spread over a wide area around the airfoil that looks like this. The pressure differences are caused by the previously seen changes in flow direction and flow speed, and the changes in flow direction and speed are caused by the pressure differences. Air at the top is pushed in towards the center lower pressure area, and air at the bottom is pushed out, which causes the flow deflection. Air traveling through the low pressure area speeds up, and air traveling through the high pressure area slows down. All of this just keeps going in a loop, and the airfoil is majestically lifted up. Both thrust and lift help to keep a plane in the air so that you can go from continent to continent and make the world a more connected and interwoven place.